charts, and people could do this and that, you know, like, so there are lots of things that there are robots that technically don't follow. And definitely nature would be one of those. Any proprietary journal charges a fortune for reading research that we already paid for.
So certain publications, like I can't remember if the New York Times is semi-paidable, like some of the ones which say we will let you view 10 pages per month. It really depends on which website it is. For example, a number of those pages implement that via JavaScript, and we don't execute JavaScript, and we don't have like persistent kind of like cookies or things like that. So it would be similar to the Google crawler, which the Google crawler obviously is able to get access to all those items. But it really depends on like which publication, what their policy is about that sort of thing.
Do you currently basically make single-page apps?
So single-page apps, yeah, we don't execute JavaScript. Now, the good thing is that most single-page apps are usually pretty worried about actually still displaying the content, because otherwise they won't turn off. And I think Google's starting to get smarter about it. But like almost all the other search engines are just pulling in the raw content as well. If it did become a substantial problem, we haven't seen like huge chunks of the internet missing. But if it did, we could actually end up running a headless web browser and executing that JavaScript as well.
So this is a really exciting project that's been done with Common Core Data, and Raymond's going to speak about it a little bit. Raymond?
Well, I'll be honest, I don't know much about it, but it's something that I'm very interested in. I think there's been a lot of deep work done with Common Core Data, particularly from academic communities. So one of them is this Web Data Commons, where they set out to extract as much of the structured data. So that means any microformats, like any HTML tables. I think they've also, I don't know if it's in this slide, done a calculation of the hyperlink graphs. So they've extracted all the nodes and links between the pages. So instead of, for example, those of us who are interested in Common Core Data might not want to work directly with the raw data, we could make use of the data that's already been calculated for other research purposes. So I'm definitely inspired by that, and they've also published the source code for how they do their extraction. So from a pedagogical point of view, I'm interested in studying that and extracting something that's simplified and maybe salient for teaching purposes. I'll be looking at that.
And this is a great example of, like, so the last, like I said, studying something about the real world, studying, doing machine learning, training algorithms. And this is an example of studying kind of the nature of the web. The first thing these guys did, the very first project out of Web Data Commons was looking between 2008 and 2012. I think they've updated it since, but 2008 and 2012 metadata formats. RDFA versus microformats, like which is more popular now, and then they did a lot after they got that information. They then said, okay, now why do we see a change in the spike? Who adopted what? Like that. So this is studying the nature of the web. And the next topic is a really cool project Stephen did, studying the nature of the web.
Right. So when I was at Harvard and I was in my master's course, this is a question that had been rolling around in my head for some time. It was basically how pervasive is Google Analytics on the internet? So Google Analytics, for those of you who don't know, basically it will track users on a website. It's great if you're, say, interested in how popular certain articles are or how long people spend on a page. But it really is pervasive. And people have generally spoken about the top million pages on the internet. So for the top million, it's 50% actually use Google Analytics. For the top 10,000, it's 65%. So that's already a substantial portion of web traffic. But I was curious how far that actually went. So how much, basically web history does Google Analytics capture across the entirety of the internet? And the only way to really do this is kind of vaguely similar to PageRank and how it's calculated, if you know about that. It's the same sort of thing as with PageRank, the idea is it's how popular pages are or how long you'd spend on a page if you randomly clicked around links on the internet. So I want to know if you randomly clicked links on the internet, how much of that would Google Analytics capture? And it turns out to be a really quite scary proportion. Once you get to, I think it was like 30 or 40 million domains, only about 30 or 40% of them use Google Analytics, which sounds reasonable. But it turns out if you're randomly clicking around, there are two things that factor in. The first is that obviously the most popular pages are the ones you end up most commonly actually on. The second is that refer information is carried through. So if I went to sanfranciscochronicle.com and then went to a different website, that new page that I ended up on will actually be told I came from San Francisco Chronicle, which is, again, very useful information. If I've got an article and people link to it, I want to know where they're coming from. But for Google, that means that they actually get 2 pieces of information for every single analytics point they get, which means that you only have to click 1 in every 2 links being Google Analytics for them to capture the entire path. So they actually capture about 60% of web browsing history, at least from my estimates, just like without doing anything else other than having Google Analytics on the 30 or 40% of the internet. So it's pretty fascinating. Like, I was only able to do this because of Common Crawl existing as corpus. If I had to go through and do this, downloading myself and then analysis myself, it would just take too long. It would be a feasible project. So we've gone through the file formats. If anyone has questions on that, feel free to ask. One of the other really nice things is the file format itself. It's basically compressed in a way that you can randomly grab a single page. So if you've got an index and it says, okay, like I'm only interested in all pages from Berkeley.edu, then you can just go ahead and grab those. You don't need to process the entirety of the corpus.
So, so for my colleague that wants to do a Lucene practice exercise, Lucene being text-oriented, you'd suggest that the WAT and the WET would be the right targets?
Exactly. So
maybe just, is there some way, a one-liner, that you can get certain header lines out of the WAT?
Yeah, so we'll come to the example in a sec, but one of the examples is literally pulling out just which server. So with the WAT file, it has the HTTP headers, and you can just ask like which server served up this page, or what is the title of this page.
Super.
Yeah, sorry.
You said the WAT file server links. Was there the URLs for the text?
The URL and the link text, and also the type of link it is as well. So whether it's like an APREF or a script tag or a CSS. So yeah, that's actually a very good question. Oh, also it stores links to images too, which provides some kind of very interesting things. Like early Google image search, for example, the only way that it kind of knew what was in a page was the alt text on the image or the surrounding text as well. So at least some of that information is kind of carried through.
So yeah, now we're going to talk about this a little bit. We're going to switch off of PowerPoint and onto a browser.
So speaking of the exact question that you had then, like, can you pull out a specific file from just the WAT file, for example? You can indeed. So we've started creating a Mr. Job. So if you've heard of Mr. Job, it's a very easy way of running Python on Hadoop. Basically, it's beautifully simple. It handles almost all complexities for you. You don't have to touch Java at all. Raymond will be talking about how he's used IPython in parallel in a second. But with this is kind of a good way of leveraging the existing Hadoop ecosystem. And for that, we've actually included 3 different kind of example tasks that use the 3 different file formats. So one is like just a typical kind of tag counter to get the usage of certain HTML tags on the internet. So you could maybe analyze how the composition of the internet has changed over time, or how popular certain heading tags actually are. And I'm terrified that people are using H14. But so that's like a very kind of simple and concise example. Yes, some people would put that. But like that example is about 20 lines when you also, let's say 40 if you include the actual tag counter as well, to actually run across the data. And specifically as to your question, the metadata is actually stored in JSON, so you basically pull out JSON, load it up, and then you can check to make sure it's a response, because we actually include the exact requests that we send to the page as well. So whether our request specified we prefer English or certain specific content types. And you can just pull out from the HTTP response metadata, headers, server, or in that case it'll be like payload metadata, content, and then it'll be title, or whatever else. So this we can go through and just have a look at how popular certain pages are, certain web servers are on the internet. Yeah. So can go through. I'm really interested in looking at this and seeing specifically so if you have a jump through, 1.60, that's pretty near, but then we start getting to 1.19, and at that point of time, a lot of these pieces of software have had substantial security issues to the point where a lot of these are probably exploitable. And to know how much the internet is actually exploitable is a very interesting question.
Well, as of Wednesday, that number increased. But
anyway,
wait, does everybody know it's fast?
Yeah. So you yourself are pretty comfortable setting up the HDFS cluster and then loading in this data set. You do that. Before coffee in the morning, say.
It takes, let's say, an hour, maybe a very long coffee break. Mainly just because it takes a lot of time. One of the reasons we don't want to run kind of AWS tutorials in full unless we have a full day is because sometimes it just takes a while for machines to spin up. Sometimes AWS is taxed. They'll tell you that they'll never get taxed, but sometimes it takes like,
So you have AWS machines, you spin up some HDFS, you use the Cloudera?
So one of the things is we don't generally use HDFS. We put all of our stuff on S3 and that's where we pull it from. So if you're processing the data, you don't actually have to spin up HDFS or at least worry about HDFS.
You're familiar with Amazon Web Services to know when we say S3, it's their storage bucket. People understand the conversation Brian and Stephen are having about HDFS versus S3?
So if not, basically consider it just as a normal, like, basically a directory you can list and pull files from. It's at the back end just a web server that lets you pull down files.
And also, you have to take a break from talking about your thing, but after we finish up yours before we do Raymond's, Brian, you have to tell everybody the bash story. Not everybody heard it.
So the kind of bottom part of this framework, it lets you, if you're running locally, you can just grab files locally to test and develop. If you're running on AMR or Hadoop, your own cluster, you literally just grab and connect to the S3 bucket. You don't have to store this data on your HDFS cluster at all, because that would be double copying and
So there's code included right there.
Yeah. So
thank you.
Yeah, literally that is where are we? So if you're going to do the server analysis or the web count or whatever else, that is all you actually need to write. So we're really aiming to have this library be very simple for say, classes to actually use and teach initially is an example of how to actually use MapReduce without having to go through all the complexity. If you are interested as well, we do have a Java example which uses Hadoop natively, but it's not as beautiful. I will simply say that as much.
Right.
It's got the actually exact same examples, but for example, the server type map, the exact same code that is here expands to this in Java, which is not as beautiful in my opinion.
Nice work, Stephen.
So I've kind of gone through how you use Mr. Job, and Raymond can go through basically IPython and
IPython. But you have to tell the story. So he said that number went up. Stephen said, look, but you can see maybe we gotta count what big a percentage of the web is exploitable. And then Brian said that number went up because?
Well, if anyone was under a rock for the last 2 days, basically there was a vulnerability in Bash that was discovered, and it turns out that for the coders in the room, when you invoke an executable on the Unix environment, it carries with it environment variables, and it doesn't take a whole lot to carry the environment variables through, say, Apache, an Apache HTTP request. So by a carefully crafted HTTP request, you can execute code on the server, and the whole world is turning upside down. I caught it first in my lab group, so I'm getting good feedback. It's a problem.
And those are the kind of things we'd like to run through when we talk about Raven. So we want to teach this we want to teach these kind of things as tutorials, right? Maybe it's a 3-hour tutorial, maybe it's an all-day tutorial, but we'd like to see people actually run through that themselves, and then or say, okay, we're going to go through this step by step with you, and now you go and do a minor variation on it. Something that's not going to take a huge amount of change. You just watched this, now go and do. So here's another one that Raven's been working on.
Okay.
Can I ask you a quick question? What's the kind of audience that you're imagining for these kinds of tutorials? Are they people who are already highly fluent with Python or with Amazon Web Services and things like that?
So I think it's Python. I think originally it's Python. People who know Python, and we'll teach them Amazon Web Services. It's not that hard, but ultimately the goal is teaching people to code, right? Like teaching people who and they have a vague understanding of Python, and to sort of maybe agree with it that we want to teach people who are not that familiar with Python.
I think to be honest, that's part of what I call the pedagogical challenges in terms of when I think of this type of material, I kind of think of the students at the end. Near the end of my course, and you can think, okay, well, part of it is if we can understand better and really refine the teaching material, you can, which we said earlier. But there's going to be a certain minimum number of concepts that that you have to explain, and then even more importantly, people really have to have experience and really, I'd say, work it into their bodies and stuff. I think of it like you have to sit with concepts, you have to do things, you have to make a lot of mistakes until it becomes second nature. And there's only, I mean, when I say, well, let's try to teach this in 3 hours, I don't know. It's going to be interesting to see how much you can boil things down. Is that?
In 3 hours, absolutely, you have to find them walking in. In a
If
day,
people know.
maybe.
I was going to say, so one of the other things we're really interested in is kind of data journalism applications. And for that, a lot of journalists are really interested in pulling out some of these things, but they don't have strong coding skills at all, which is why I really want to emphasize Python. Java is, at the moment anyway, kind of the more optimal way to process the data, but Python is the way, the better way to actually, for the human to go through and actually pull this data out. The other one that I'm really interested in is big data courses, because a lot of the time when they say teach Hadoop on campus, like I had this experience back at Harvard, they talk about big data sets, and even if you're using English Wikipedia, which is probably the top end of what a lot of courses went up teaching, that is 4 gigabytes compressed, it's 40 gigabytes uncompressed. But 40 gigabytes uncompressed, you can get an Amazon instance for 60 cents an hour that has 64 gigs of RAM. That entire thing fits in memory. So a lot of the time they aren't actually teaching, I guess, what big data you'd end up hitting in industry, whether it's log files or raw web data or Twitter, I think, someone was saying that they were going through and processing some jobs where they were going through 10 petabytes, which the funny thing at that point is that JavaScript only supports 2 to the power of 60 something, but the number of bytes, basically the number of file system bytes that you actually process, they try and send to the browser, that overflows the JavaScript integer. So that's the sort of insanely large jobs that they're looking at in the real world at the moment.
I want to talk a bit about an alternative approach that I've been using to try to work with common file data. And it kind of ties more to the way I've been doing computation in Python, which is to use the Python notebook. So basically, when I look at the common file data and read the documentation and see there's these different file types, one of the first things I want to do is okay, can I write a piece of code that takes one of those data files and actually make sense of it? And one of my efforts have been helped by actually studying Stephen's code. So when Stephen wrote the things for Mr. Job, kind of the bottom part where he actually needs to parse the files, I kind of borrowed that code and put it into this IPython notebook. So some of the things I've been working with a lot is to use and do things much more interactively. I think one of the challenges of using Hadoop is that it's, well, I don't know if it's fair to say it's not terribly interactive.
It's not terribly interactive. It's not terribly anything.
So you just want to. So the approach I take is to try to understand small pieces and then build on top of it. And so the things I've been exploring is using the IPython notebook, and specifically something called Docker, which is Docker is think of it like, technically it's like Linux containerization, but what that means is that we're able to wrap pieces of software or dependencies together and move that around more easily. And so one of the challenges is that when I'm doing computation, I like to work first on my laptop using an environment which I'm familiar with. But where I need to do the computation ultimately at scale might be a different environment. So I use a MacBook Pro, and where the computation I'd like to ultimately do when I want to crunch a lot of files is on Amazon EC2, on some version of Linux. And so those are different enough environments that one of the big pain points is actually installing software, installing the right piece of software, and making it work so that you can make it work on your laptop, but then you try to move it somewhere else. And I find that a constant pain point. And so Docker has gotten a lot of attention in the development community. The idea that, okay, well, if I can make it run Docker in one place, like inside a virtual machine, something from that. Then I can then move it to, say, Amazon EC2. So that's one thing I've been experimenting a lot with, and I can follow up offline or show a little demo later. And that's been helped a lot by the fact that the IPython team has been also producing like Docker images of the IPython notebook. And so if you look at the code that I have in the references, that I'm basically building on top of that. So they've done a lot of the work of packaging up what it means to run IPython and its dependencies, and I've just added extra dependencies on top of that. So I run locally on my laptop, like reading 1 or 2 files, say, okay, I can get it working for 1 or 2 files. And the question is like, okay, how do I scale that up to a larger number of, to do that efficiently? And I think that's part of my own struggle right now in terms of learning this. I've been using one of the standard libraries, the multi-processing library, and I've had some success with that, at least getting up to like working within the constraints of one machine. And so on Amazon EC2, we can do is like, okay, well, first run it on a small instance, and then if it's working, I just close down the small machine and run a bigger machine. So that has, so the biggest machine has something like 60 gigs of RAM and 32 cores. So that's much larger than my laptop, but still, you can do better than that. And then, so some of the questions I've had is, how do you expand to working in a cluster easily, still using IPython, the IPython notebook and Docker. And so those are, I think I just put those out as questions because I'd like to learn more about Star Cluster and Elastic Cluster. These are alternatives that all I know is their name. I haven't done anything with them.
Anyone here work with either of those?
There's Star Cluster, but maybe I don't know enough about it, but isn't Star Cluster just a means of starting up a cluster, and it's not going to deal with the issues of cross-node communication and things like that. And it'll start up a cluster for you, but then and maybe you'll get MPI installed and stuff like that. But then it doesn't seem to be.
I think a lot of the computations that I'm interested in, there's not necessarily a lot of communication that you need among the cluster. It's like, well, I can run this like one calculation, but I need to run like 50,000 of them and do them quickly. So a lot of the problems that at least I'm starting with are embarrassingly parallel. So it's like start up a cluster, and if I can make it look like one giant machine with all these clusters, then that is.
Yeah, I don't think Star Cluster is going to do that for you. It's going to give you a cluster with all these nodes, and you got to figure out how am I going to get this comparison and parallel job to run.
So I would also mention, so Star Cluster you can spin up Hadoop from memory, which one of the things which we're very interested in is that when people do actually want to do experiments, when they do want to run a large Hadoop cluster, a big issue is the easiest way to do that is something called Elastic MapReduce. So it's Amazon's hosted Hadoop solution. The issue with that is the cheapest way to do experiments, and the way which I suggest to everyone, is to use something called spot instances. Which means that if, for example, a machine would usually cost, say, 5 cents an hour at Amazon, a lot of the time they won't actually have all these machines in use. So you can get it for like 3 cents an hour. So it's huge cost saving. But the issue is Elastic MapReduce has a flat fee associated with each machine type on top of it. So at the end of the day, you'll end up paying like maybe 3 cents an hour for each machine in your cluster, but for each of those, you'll be paying 10 cents an hour just to have like EMR manage a cluster for you. And that, I mean, obviously increases the cost of experiments like 3 or 4 times. So the best thing would be that each person could spin up their own cluster. We'd ultimately love to release some of our like Hadoop spin-up scripts, but they're tied a lot to our kind of infrastructure we need versus generic experiments. So we're looking at Star Cluster and Elastic Cluster to basically give that simplicity to.
Well, so the conversation could easily just get pulled into DevOps things. I don't want to do that here, but I do want to mention that I worked with a post OpenStack sort of rev, and it's Python oriented, and the instantiation is done via Ansible, which is Python, and OpenStack is Python. And so the aim of those people, there's some very fast movers doing some other data things, and the goal of that was that the researcher stays in Python. Python, Python, Python.
Yeah.
And some of the other systems, this is all very much in development, and it's its own major topic in itself.
Yeah.
I have seen, to add to that list, I did look at it. That's very cool.
I'd be interested in hearing about that. But yeah, for that exact reason, we don't want people who are running experiments to be worried about running a cluster. They should be focused on what they're doing.
Yeah.
Like, each person shouldn't have to learn how to spin up a Hadoop cluster themselves and manage HDFS and blah, 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 blah. So yeah, we're very interested in that.
Yeah, so I think it's basically, like, figure out this type of stuff has its fascinations. Ultimately, I think it takes too much of my time to try to figure that out. And so it's my coming here and say, how do we work together to figure out, I think, a good set of techniques that would be useful, for example, with the common core data, but I think we're all interested in other data sets too. So the idea that using the common core as and its riches, and by figuring out how to process that efficiently, effectively, but then also how do you apply that to other data sets. And I mean, I really love the IPython framework, and so kind of staying within that, but also recognizing that ultimately that will have its limitations too. So I just throw in other things I would like to explore. So I imagine, like, I think, okay, being in Berkeley, hearing about Apache Spark, and thinking like, oh, is that going to solve my problem? So I need to like just learn Spark and then run Spark on top of Mesos. I flew around terms I don't know much about, but will magically solve my problem, because all I really want to do is run some calculations in the common problem, and I don't want to spend too much effort managing clusters. But so what is it? What are the frameworks that will give this a nice abstraction that lets us focus on the data itself? And I don't know the answer. But I think so. It's what I'm curious about the experience of people in this room, and also the question of then can figure out what are good solutions and how do you teach it to other people. That's the question I have.
Do you want to share your doc right now? Or do you want to just please get?
I'll show it later.
Okay, yeah.
Otherwise, I think I have to find some plugging stuff.
Okay.
So that's definitely have to open up for a conversation. This document, I threw together different questions. But what do other people think, or what people are interested in?
So, for example, I know that today we've got someone from Spark team who's interested in possibly using Common Core Corpus for topic modeling. Do you want to mention that?
Tell us about it.
Yeah, so I'm an undergrad working in the Amp Lab, and what we're trying to do is many things, but what I'm working on specifically is topic modeling, and right now we're, I guess, testing our code on a smaller scale, but eventually we do want to use a common core data set and topic model on that. So I guess that's the quick summary. So eventually, I guess we'll be talking to people a little bit more, figure out what's the best way to do it.
Do you think Apache, see, I don't know much about Spark, but let's say, do you think it's going to, I'm looking for a framework where, let's say if I learn Spark, and then can I just quickly start up some cluster that Spark's going to manage all the complexity?
So when you use Spark, I think it's been a while since I've actually spun up a cluster, because I was gone for the summer doing other stuff.
Okay.
But I believe they have startup scripts, and once things are running, it's fairly easy. You don't manage communication or anything. Once the servers are running and you run your code, then it runs. So.
But I mean, I don't understand what the problem is that you're going to solve with Spark. Like, where are you actually hitting a bottleneck, or like where are you hitting a coordination problem?
Spark's big motivation is to kind of cover up one of Hadoop's weaknesses, and that it's not very good for iterative algorithms.
But I mean, do you need?
I think-
I don't see where you need Hadoop either. I mean, it's like there's just.
I guess there's two different problems. One, setting up like the servers or stuff you're going to use for your computation, and then what software you're using to leverage that. I guess those are two separate things.
I thought his problem was he needs to do some massively comparison, like parallel calculations to deal with this huge data set. So he's not going to do that on the machine, so he's trying to do it with Spark type stuff. You know?
But I mean, if the data's already in S3, I mean, do you want to take the data and copy it all into a distributed file system?
So
that doesn't-
you stream it to the machines as they process it. So you don't
Right.
need to store it.
If we need those machines set up to do the process, we need to be able to send out instructions to all those machines to do this processing in parallel, right?
Yeah, I think I'm just at this basic point where I haven't, like maybe
Yeah.
next week I would know the
I
answer
don't know
to.
how much,
But
you know Spark working with like Amazon, but kind of the flow usually is you develop locally, make sure it works. You change a couple paths, like you point to S3 to pull your data. You push your compiled, I guess in this case it compiles the Java jar. Push that to your cluster, basically execute commands as run my stuff, and then it manages running your code for you. So you still have to worry about writing your code, but you're writing code that's like not having to manage communication. And you can run it in Python as well. I haven't actually used the Python interface because I'm working in the Spark core, so it's all Scala. But there is a Python interface to do it.
So on the mechanics side, the Spark training, they use the Cloudera stack to instantiate all the pieces. And the modern thing is, code goes to data. So instead of having one pipe that you're pulling data from, and then one or more machines that are reading from one pipe, that's sort of a mainframe model. The distributed model is that each node knows the range of data that it has, and then the data is distributed multi-node, and then the algorithm can distribute to the data. Each node processes the data, and it comes back and combines.
Yeah, I mean, I get that, but I mean, it seems like you could just have like so SQS would be the Amazon like actual service, or like if you wanted to run something more generic, you could run like Redis.
SQS is
Simple query service.
Simple queuing. It's like, I mean, basically, you just need a queue of work. I don't even understand why any of your machines even need to know about each other.
So
to
if
some
you're
degree,
doing common
Hey, if I talk, can you guys hear me? Can anyone hear me?
how common problems done, but you're not like, iterating on your data.
Well,
yeah. So basically, what you suggested is actually the way that Web Data Commons team do it. They actually do use SQS. They have a number of machines, which literally SQS is like, here are a whole bunch of files that need to be processed. Here are a whole bunch of nodes, grab one off the queue. It's really just a job of coordination. Hadoop is the most generic hammer to bash against the most problems. So a lot of the time we literally do something equivalent to this, where you just want to have the like a single file to be processed in some way and then thrown back. But Hadoop gives you a number of really nice tools when it comes to operating across so many terabytes and so many files. In that, if something fails, for example, or if you have a node that is incredibly slow, Hadoop, for example, preemptively go, okay, look, I'm at the end, I need to wait for this step to finish, and currently there are 20 machines sitting here doing nothing. And these 3 machines are having a really hard time processing this file. It might just be that they've got a screwy hard disk or something. So they'll redistribute that to the spare machines, and whichever one finishes first, bam, you're good. So like it does help out in situations where it really just is embarrassingly parallel and you need no communication, just because you've got someone looking over it and can basically help maintain the health of the cluster. But the other thing is, for us, like once we've got a Hadoop cluster up, that means that we can do everything we need to do, including some of the steps. For analytics, for example, we do a lot of aggregation, so we do need between node clustering. And the other one, for example, is when we're generating crawl lists for robots.txt. I don't like this necessarily, but not to avoid a central point of communication. So if we've got like 5 machines in the room, for example, and they're all trying to crawl Yahoo.com, and you're only allowed to crawl it once every 30 seconds, if they're all trying to crawl Yahoo.com, they have to coordinate some way. So Nutch avoids this. Instead of having some single server that keeps track of when you last crawled a page and everyone asking that and that thing crushing under flames because it's overloaded, it'll actually separate and so aggregate all the tasks or have only one node handling all of Yahoo.com, for example. So it basically, Hadoop is the most generic tool that gives us the widest range of applications we can throw against it. But indeed, for the tasks you're talking about, entirely embarrassingly parallel, it doesn't necessarily add anything compared to this except the retry capabilities.
Hey, can you guys hear me if I talk? Can anyone hear me at all?
Maybe. I don't know. It's what you would do
Hello?
with topic modeling, common crawl, looking at applications, and I'm having fun thinking about
Yeah, so right now, I guess our purpose is for using Common Crawl to begin with is to make sure that we can scale to that data size. So we're using it, I guess, for a large part probably for machine performance, see if we're scaling our code scales well, and see, I guess, hopefully, I'm guessing that people have crawled the web at some point using different software. But I guess that's a good question. I don't know exactly what we're going to do yet. I guess if we make the algorithm and it's fast, then other people might be interested and they'll explore and find interesting things that we would never have thought.
So one of the very interesting areas for a lot of NLP at the moment is surprisingly enough newspapers. They want to, for example, use named entity recognition to be able to pull across and combine all the articles which Obama has mentioned and show a histogram of over time. They're really trying hard to fight off the kind of digital age, or at least add some value to the digital age such that people want to pay for their services. And NLP seems to be a really popular application for that. So yeah, it's also interesting for the fact that a lot of Common Crawl, a lot of the analysis, a lot of the research done, generally people aren't aggregating stuff across. They're processing it in some way, pulling out a very tiny amount of information and then pulling that all together at the end, versus topic modeling where you really do actually end up, at some point interacting between the majority of the data set, or as you're reducing down, trying to find the most indicative features, you actually do have some sort of cross pollination from all the data, which is something that, at this scale is really quite terrifying, which is why the Spark guys are trying to...
It's just the most giant job that you can try to pull off?
As far as we can think of,
Yeah.
I can't think of much else that would be larger than that. We're kind of imagining it as this huge graph problem, where you have documents and unique instances, unique words, and the existence of a word in a document is an edge between those two. So because you can imagine the size of that graph is gigantic.
That is. So the hyperlink graph, which we mentioned before, they have 128 billion links between pages. So if you're going to drop to words and have a link graph like that, I'm very interested to see how you guys handle it. There are some really nice simplifications these guys have also done with the hyperlink graph as well, in that if you're interested at page level, the data set is absolutely enormous. But if you drop it down to a host level, so instead of knowing that reddit.com/r/something links to this other page, you just know that reddit.com links to wikipedia.org versus all the information, and that turns into really quite a tractable problem to the point where you could use it in, say, a data science class for exploring graphs and calculating PageRank and seeing how that actually shows up on a real data set of the internet.
It's alpha code, but currently part of Spark calculates PageRank as well. It's alpha currently.
So does anyone here thinking of something they might use Common Crawl data for? Or maybe something that would be easy to teach. So Raymond's been talking about we want to be able to teach it in the workshop, possibly create an open educational resource module that we could then push out to different colleges and universities and say, here are a set of exercises and things that you can use to teach some big data techniques.
It would be interesting to have a short section during AmCamp, which I think is in November sometime. For those that don't know, AmCamp is an event put on by the AMP Lab, that's free for students and some charge for people that aren't students that basically teaches you how to use Spark. I think it's like a whole day or 2 days or something like that. It might be interesting to have something common.
Yeah, that would be great.
I don't organize it.
Right. No problem with you, man. When we think about what to teach, like what's something that's simple enough to do but is also compelling, So when we talked about the performance contest, we talked about graph analysis, remember? And then maybe do you guys want to talk about some of the examples that we're having a workshop actually at Stanford. It's not part of Stanford. It's just that Stanford gave us some space. It's with us. Jim Hendler from RPI and Lindy Hall from University of Southampton, UK. It's a web science workshop, and we're going to spend some time on Common Crawl. And remind me, the examples we're using there is in JavaScript.
Yeah, so with that one, we're primarily interested to give them a very simple way of looking at what the most popular JavaScript libraries across the internet are. And one of the issues with a lot of these examples is we want something that will work at a small scale. So on their local laptop, and then obviously something that turns into something far more interesting once you run it at a larger scale. And for example, in that instance, the hyperlink graph is something that isn't interesting at all if you only run it across a single file of 10,000 pages, for example, because the most probable thing is that all of these pages will be disconnected, and until you get through a billion or so, then at that point some of the links between pages will start to actually merge. So yeah, we're looking at trying to find the most popular JavaScript libraries because that's something that will work at a small scale, but then should become more interesting once you get larger.
And it shows, look, this is what web science, this is what web data can do for you. So we're definitely interested in any ideas people have of well, this would be simple but boring. This would be interesting but too hard to teach in a short time. Oh, here's something that maybe you guys could get train people on.
I don't know how easy it would be, but there's an undergrad CS course. One of the projects is a MapReduce the previous year at some point, which is the one that I did. And the basic question was, given a social graph, how many jumps on average do you have to make to get to any random given person? And that was an interesting problem. But I don't remember much about the project. It was like a long time ago.
I like that. And someone once did a study of how many pages have Facebook, or some sort of Facebook. It was very high.
Yeah. So the interesting thing about that was this is literally kind of hobbyists who decided as a pet project they wanted to know how many pages on the internet reference and link to Facebook, and how many of them use Facebook's Connect, which I think still is in existence. And it was something like 30 or 40% of all the pages that they went through. And they did this for fun as a side project. They ended up writing their own Ruby stack instead of using anything like Hadoop. I think they used SQS or something similar. And yeah, for $50 they went through like 400 million pages or something like that. So.
Any other ideas? So I like that one about how many links does it take to get to someone. Any other thoughts of? Does the JavaScript one sound boring? Are there other things that we should get into?
I think it sounds interesting because I do a little bit about that. Might be biased.
Maybe.
There's kind of a sense in which it's unsatisfying to me to just count things,
okay.
Right? Because you could you could just subsample. It's not you're not really
sure.
Leveraging the value of this data.
That's true. I mean, that's the problem, right? Something is simple enough to explain quickly, but it's not super boring. I mean, if someone said, I want to intern with Common Crawl, or I have some time to work on Common Crawl, and I want to do a project, we would definitely start talking about some more than just counting.
I mean, you could get into, a actual social question. You could pick, this is actually, a colleague was asking me, how do I get information about the way things spread out from Human Rights Watch campaigns.
Okay.
Right? And so you could just say, so if you have so that's going to be really sparse. And it's going to be hard to guess what's going to link to a Human Rights Watch campaign. So you could have a seed of something that someone's actually just interested in. And then you could say what's linking to that, how can we identify what makes a successful campaign versus a campaign that just fizzles.
Or even maybe just like mapping an environment. So what other organizations, people know HRC, it's an LGBT rights organization. So what other organizations are, like what are they linking to, what are they not linking to, like what other organizations are in that space? I mean, if you look at EFF, you would expect there would be ties with media, other like and other net neutrality groups or something. That is an interesting one. I think maybe looking at something of personal interest instead of just counting. And I think maybe one barrier there is what Stephen mentioned about it's harder to do on 10,000 laptop size, but it doesn't mean we have to run a workshop on laptop size data. We can get, oh yeah, that's the other thing I forgot to mention, I can't believe it. If anyone wants to play with this data on Amazon Web Services, or if you just tell me you want to play with this data, but you just want some Amazon Web Services credit, you can get like $25, $50 credits for Amazon really easily. So if you want to play around with it on scale, just email us and we'll send you some credit codes. But yeah, so if we were making sure people were logging on to Amazon Web Services, so something like that HRC thing, I think you would need millions and billions of pages as opposed to small laptop size subsample.
Thinking about it forward, what about something like a Wikipedia game?
Wikipedia game?
You land on a random Wikipedia page and your friend tells you, get to X page, and the competition between you and them is who can get the minimum number of links to get to the page they want you to get to.
Yeah. It's like a nice old school graph theory problem.
Yeah.
Can you do Dijkstra's algorithm?
So we've been talking for about like an hour. People, I think this normally runs 2 hours. Are people restless? Should we take a break to use the washroom, or maybe stretch our legs and keep talking, or?
I'm curious. My understanding is that information extraction is hard and not really solved, like as in getting semantic information from text out of it into the out. But this seems like the kind of corpus you do. I expect you to have things outside of you that you work with that kind of usage of this data.
So like entity resolution, so working out when you're referring to certain concepts.
More trying, yeah, I guess referring to certain concepts, but then also the relationship to like Freebase and got bought by people. Like they've got people with that information extraction there that enter in Freebase. I don't know whether have you seen applications of how information extraction on the call set so that you can replicate from that?
So we've seen some amount, but I mean, not a lot of what I was expecting. Like one of the easiest ways of doing this is people already do this with Wikipedia when they see the word, I guess, Apple, for example, and it contains a link to either the Apple computer page or the Apple, actual fruit page, and that provides a way of actually, I would consider it like gold standard data. So some human actually tells you this is actually what this apple means. So that gets rid of like ambiguity in that situation. So that's one level. The other interesting level is to actually take that to the internet. As I mentioned before, English Wikipedia, for example, is an amazing data set. It's very well curated, it's beautiful, but it is also only 40 gigabytes in size, like a surprisingly small number, considering the scale of the internet. The other way you can look at it is actually go to the internet and then go through the pages and find all the pages which link to Wikipedia, of which you have got very good and very curated information. And so if it's a random page on the internet and it says, Apple iPhone and ends up linking to Wikipedia, there you've got your ambiguity resolution. Or the traditional one is more kind of loaded terms. I can't think of one at the moment, and the one I can think of is Australian, sorry. But John Howard was a Prime Minister of Australia, but he's also a very popular actor, for example, and some other things.
There's two people named John
Two people named John Howard, yeah. So you want your cousin to be able to actually, or at least entity linking to be able to tell those two apart, depending on certain content or things like that. And that's the sort of thing where linking back to Wikipedia would be a very useful thing.
Yeah. After the energy resolution, you could do like extracting whole triples of predicates to from this kind of data.
You certainly could. This is kind of even more general NLP. Triples are in fact one of the ways which they do a lot of ambiguity resolution. In that, if I said the blag bit the person and the blag barked, you could guess that the blag was a dog. And that level of knowledge is something which you can certainly capture in this. Usually, You can do more complex types where you actually analyze a sentence and the furry flag is adjective describing flag, or usually they just consider a window around it. And most commonly, this word is associated with these other words, and that's like perfect for this data set.
Have you seen it done? On
this one, I think we have in one of the Norvig awards. So
there's anything maybe the code contest. There was a casual one done in a code contest, but not a serious research paper yet that we've seen. So one thing that's Stephen mentioned, we didn't see that work. The language model paper that we put up, we didn't see it until after it was published, and then we contacted them and we've been talking with them. But we have a little bit of a difficulty in understanding exactly who's working with our data because we don't know. Anyone can pull it down. Amazon public data sets where our data lives, we don't see usage reports. So really the way we find out about research is going to Google Scholar and looking at papers we already know about and seeing who cited it, or like putting a Google alert on. And so there may be work, but right now the only work I know of like that was for a code contest, and it was much more casual.
So just to mention another one that did just that was Dirt Cheap Web Scale Parallel Text from Common Core. Parallel text in NLP is basically the same sentences in both your language A and language B. So it would be maybe the menu for a restaurant in Canada, where one chunk of the web page branches off and it has the menu in English and then the menu in French. And so this is incredibly valuable for the fact that you can use this to kind of inform machine translation tools. And they actually go through and process Common Core and end up pulling out 32 terabytes of parallel text in a day at a cost of $500. Hopefully that could be improved. But even then, $500, if you're, creating a data set of that size, if you actually have people working on it, you're going to burn through $500 in a day anyway. Especially with NLP, there's a huge issue with annotation in that it takes a great deal of time to set up the actual problem and then get people with the right skills to do that. For example, languages would be terrifying because you need to find the right combination of people who know English and French, or French and Italian or whatever else. Anyway, so they pull all of that out, and then they end up getting, so Blue is a metric for basically improvements in machine translation score. I won't go into it, but it's a really large improvement just by pulling across all of this data. So that's another kind of example of just something you wouldn't be able to do at a small scale with like any other data set, just because this is kind of like latent information that people have contributed to the internet.
Just a money question. Do you have the requester pays bit set on the S3?
So again, the public data set is where the public data set is a great resource. We're not the only things out there. There's Thousand Genome Project. There's there's just tons of great.
So it's not, you can mount the S3.
No USBs.
So yeah, you can download it straight. For example, we mentioned the Stanford team who did the language models and n-grams. They downloaded the entire thing for free, and they're actually downloading to Edinburgh.
And they drove Porsches home after they did it.
So yeah, but in Edinburgh, they actually ended up, I think they were using 97 or 98% of the entirety of the bandwidth on campus to download these tools for free. But yeah, so literally you can get the entirety of Common Core for free as long as you have somewhere to store it, or if you're really sadistic, just type it into DevNull. So yeah, you can download it for free.
But no egress fees coming out of public data sets for ours or for anything else on public data set.
Yeah. So the only thing you probably want to be aware of is, I don't know 100% of how it's done, but I mean you can access it if you're really interested. If you don't even have an S3 account, you can get use anonymous credentials, and that will work just fine. So yeah, they don't even have a way to tie it to your usage. So yeah, so that is something we need to communicate slightly better, because people do hear S3 and they think of fees and whatever else, and pulling down any portion of this data from S3 is really quite a large amount of money to be spending. We're lucky with the crawl in that with the crawl we pay for it ourselves, but because of spot instances, we only pay about $100-ish a day to actually run a cluster that is crawling the internet, hundreds of gigabytes per hour. And with that, because it's all incoming data, Amazon don't actually charge for it at all. Surprisingly enough, we actually send, even though we primarily download, obviously, just sending the requests to download all the content is about 6 or 7 terabytes a month that we have to pay for in outgoing bandwidth, which is not cheap, but it's far better than paying for the incoming bandwidth as well. And also, if people are interested in hearing a bit more detail about the actual crawl itself, which I'm not going into today, there's an advanced AWS meetup that I'll be speaking at early next month.
Oh yeah, and that's incentive. Can you also put up the one about the web observatory that we have in the Bay Area? So if people, next week is the web science workshop I was talking about. This is a group that I'm one of the co-organizers of. It's not always about common cloud data. The last talk was, but we talk about all sorts of things. We talk about geodata, weather data, and this is, so this particularly is the workshop we're going to run next week with web observatory about, and we'll be training people to use common cloud for JavaScript counting, and then some variations and debugging some visualizations.
And there are a number of quite interesting people going to that as well. For example, just we've got like a data engineer from Internet Archive who we collaborate with, and then also Greg from Blecker, who he runs like quite a large web search engine, which he's the one who has even more experience than us as far as crawling the web and all the issues you end up with that as well. So if you're interested in speaking about that sort of thing, it's a great resource.
And like I said, if you want Amazon credits or if you want a subset of the data to work on your laptop, we're happy to provide them. Please put the last slide. We're all just Lisa at Common Crawl, Stephen at Common Crawl, Raven at Common Crawl. But yeah, if you have any questions, please feel free to email us. If you have any ideas, we'd greatly appreciate it. We'll buy you a drink or whatever other thank you we can give you if you have ideas for things we can teach or just ideas that, interesting projects that can be done with Common Crawl, even if you don't want to do them yourself. You're just like, hey, you know what would be a neat use to do this? We can find the volunteers to do it. And honestly, so we had a call with a Common Crawl volunteer yesterday who's done some nice tutorials for some things. And we were talking about doing a Ruby tutorial. And he had this idea that was kind of silly. And he said, well, I'm thinking kind of whimsical. And I said, we actually need more whimsical. We have a lot of serious research papers. We need a few more things that are just like kind of silly and catch people's eyes. Like, do people remember Bitly put out that thing where they said, everyone thinks the internet is for looking at pictures of cats, but we've analyzed all the Bitly links and actually there's more pictures of dogs than cats, right? Just that's cute, It's like, it is counting. I agree, it's simple, it's counting, but it's cute. So, fun or whimsical or just, like project would be great. Any ideas you have would be really grateful. All right, thanks for your attention, guys.
Thank you.
I'm kind of lost in ideas, but I'll probably.
Excellent.
Yeah.
Well, thanks for coming.
Good to see you.
Yeah. Okay, you're plugged in. I'm over there. That's around.
So I got another.
Okay, so Harrison has already told us about making it code for librarians. Super excited about it. And then another group. And then what's it? No.
Thanks, Dave, for doing this. Yeah.
Yeah, I guess I'll bring this. Stop this.
Oh,